Hello everyone, welcome to Neelam tutorial. And in today's video, here we are to deal regarding some of the very important reactions of aldehyde and ketone. And the reactions, most importantly, you might have seen aldol condensation reaction, Cannizzaro's reaction, cross-aldol condensation reaction. What are the possible products? What are the situation? Or what are the necessary conditions for this reaction to occur? So we'll be, along with some examples, we'll be dealing with these two reactions today. So what exactly is aldol condensation reaction? So let's go for it. It's saying either you need two molecules of aldehyde or a aldehyde and a ketone. So either two aldehyde or one aldehyde and a ketone. And the necessary condition is it need to have at least one alpha hydrogen. What need to be there? At least one alpha hydrogen. I'll be explaining you what is alpha hydrogen. So it need to have at least one alpha hydrogen and they need to be treated in the presence of dilute alkali. So again a necessary condition, right? It needed. And what it forms exactly? So it forms beta hydroxyaldehyde or beta hydroxyketone. And this reaction is known as aldol condensation reaction. Let me explain you this with an help of example. Here, let me take CH3, sorry, there we have CH3, C double bond O, H. So alpha hydrogen basically mean the carbon which is just beside this carbonyl carbon. The carbon which is just beside this, when this is the alpha carbon. And as this alpha carbon has three hydrogens, so yes, this reactant or this aldehyde will give positive taste for aldol reaction. But if there is no alpha hydrogen, at the time the reaction will not take place. So let me explain you. Let me take the same group again. Now what will happen is here also we have 3CH3, C double bond O and H. Okay. Now what will happen is it will be something like this. The bond between one of the carbon and it need to be taken in the presence of dilute alkali. Let me take dilute NaOH. What will happen? The bond will break, the oxygen will have negative charge, the carbon will have positive charge. Okay. Now what will happen is from the other aldehyde, what will happen? The alpha carbon, which has three hydrogen. Okay. So one among the three, let me write it like this, CH3. Sorry. Let me represent it in this way, H, H, and H. Okay. Now what will happen is one of the hydrogen bond will break. H will move in the form of plus charges and C will have minus charge in this scenario. The H will come and attach right to this oxygen and the C will come and attach to this carbon. Okay, so the product those formed will be CH3C. It was having H, so CH. Here it will be OH. And in this there is an attachment of CH2. Further we have C double bond O H group. So this is what we have, beta hydroxy acid. So this is the alpha position. In the alpha position, I have aldehyde. Sorry, there is an aldehyde. In the alpha position, there is a normal carbon. And in the beta carbon, there you can see alcohol. So this is what we call beta hydroxy aldehyde or beta hydroxy ketone. Let me take some other example and explain you the same thing. What will happen? Let me take an example. CH3, CH2, C double bond O, H. Okay. And again, I have taken the same CH3, CH2, sorry, CH2, C double bond O, H. And the reaction will take place in the presence of dilute NaOH or dilute alkali. That is what you already know. Okay. Now, what have I said you? In one of the carbonyl carbon, the bond will break, the O will have negative charge, the C will have positive charge. The other, you need to see the alpha carbon. So this one is the alpha carbon. Do you think it has hydrogen? So yes, it has two hydrogen. Let me represent it in this way. Let me remove this two hydrogen from here. And let me write it like this, as if it is C, H, and H. Okay. So what will happen is one of the hydrogen will break. And here there will be the H plus and here will be C minus. So this H will come and attach right with oxygen. And this C, this carbon will come and attach with right with this carbon to form a compound. How will the product look like? Let's see. So it will be CH3, CH2, CH, and here you have OH. Further, what do we have is we have now you need to generally student get confused. They used to connect this carbon, but you need to connect this carbon. What is right there? This carbon is only now this hydrogen is no more there. So it's only CH. So exactly it will be CH. And what is right? Other one bond is attached with it. This is C double bond O H. And right with this carbon we have a CH3 group. So down you have CH3. Okay, so it will form this type of group. And again, you can observe that in the beta position, you have a hydroxy, and there you can observe an aldehyde. So this is your beta hydroxy, sorry. This is your beta hydroxy aldehyde, okay, which is the final product of aldol reaction. Let me take two ketone and then show you what exactly happens. Okay, so we're taking two ketonic group over here, CH3, C double bond O, CH3. Again, I'm taking CH3, C double bond O, CH3. Okay, and the reaction is taking place again in the presence of dilute alkali, that is dilute NaOH. Okay, now what will happen is in this carbon, there you have C, and there will be how many hydrogens? Three. So H, H, and H. Okay. What will happen now is this bond will break. The oxygen will have negative charge, so the carbon will have positive charge, same as before. Again, you will see alpha carbons. In this case, this is also the alpha carbon, and this is also the alpha carbon. So you can use any of them. Now, both of them has hydrogen, so you can use any one of them. Now, what will happen is this hydrogen will dissociate and it will go and attach to this oxygen. And this carbon will come and attach to this carbon. And the product, those formed will look like this. CH3, C, here you have OH group. Here you have CH3, and in this C, you have this C with the two hydrogen. Okay, so H2, again, you can write it as C, double bond O, CH3. So again, you can observe right from this carbonyl carbon or this ketonic group, this is a ketonic group. From here, this one is the alpha carbon, this one is the beta carbon. So again, you got beta hydroxy, and this one is your ketone. So this time you have beta hydroxy ketone. So the final product of aldol reaction is either beta hydroxy aldehyde or beta hydroxy ketone. Now let me explain you. So what is the necessary condition? Necessary condition is the carbonyl carbon must have alpha hydrogen. Okay, so the carbonyl compound, that is aldehyde or ketone, need to have alpha hydrogen. That means if I have a compound being given like this, if it is given that formaldehyde, two molecules of HC double bond OH, okay, being treated with NaOH, at the time you will write as it do not contain any alpha hydrogen, so it will not undergo any reaction. So no reaction will take place in this. Okay. Or if I have something like this, that there you have C double bond O H group, and there you have C, CH3, CH3, and CH3. And you have two molecules. And if you are treating it in the presence of dilute, NaOH. So what will again happen is, again in the alpha, see over here. This is not the alpha carbon, this is the beta carbon. See, this is the alpha carbon, and remaining these are your beta carbon. Okay. So in the beta carbon you have hydrogen, but in the alpha carbon there is no hydrogen. So this reaction will also not take place in case of aldol. Okay. So necessary condition is कार्बोनाइल कार्बन के बगल वाले कार्बन में अगर हाइड्रोजन है, ठीक है, तो aldol रिएक्शन होगा, अदरवाइज नहीं होगा. ठीक है. Now let's move on further. There you have cross aldol reaction. What exactly is cross aldol? So we have cross aldol condensation reaction, or we also call it mixed aldol reaction or mixed aldol condensation reaction. So basically here what will exactly happen is again the necessary condition is same, that there need to be alpha hydrogen. So we are under the heading cross aldol or mixed aldol condensation reaction. So basically two different type of carbonyl compound containing अलग अगर हमारे पास दो अलग carbonyl compound है मतलब दो अलग aldehydes हैं या दो अलग ketones हैं या एक aldehyde और एक ketone है तो उस टाइम पे प्रोडक्ट क्या बन सकते हैं so let me show you that if I have two just like explaining an example if I have two molecules of A if I have two molecules of B and if it is being treated so product can be the two A can react among themselves they can form AA or I can have B with B as product, or I can have A with B as product, or I can have B with A as product. Okay, they will not be same, they will be different. Okay, so what am I simply trying to say is there will be a mixture of products, so it is also known as mixed aldol condensation reaction. Let's take an example for this. Let me explain you this with the help of example. So I'm taking an aldehyde. It's like normal ethanol, CH3, C double bond O, H group. So it is your ethanol. Okay, it's a type of aldehyde. I'm taking the other one as ketone. Okay, so other I have is CH3, C double bond O, CH3. So this is what we call N2O or simply propanone. Okay. Now I'm treating it in the presence of dilute NaOH. Okay. So over here, the only one type of product is being shown, but generally four possible products can be formed. What will exactly happen is they can be like this ethanol can link with another ethanol, or a propanol can link with another propanol, or ethanol comes in contact with propanol, and that way it happens. Okay. For now, let me show you one movement in the reaction. Again, the bond breaks. The oxygen will have negative charge. The carbon will have positive charge. Again, it has three hydrogens. One of the hydrogen right from here. This might be can be written as CH3, H, H, and H. So what will happen is the bond will break, and this hydrogen will come and attach right to the oxygen, and this carbon will come and attack right at this carbon. So it is gonna form something like this. So there you will have CH3, CH, and here you will have O. In the O there you have H group. Okay. Right beside what you have is you will have CH2 group, there you have C double bond O, and next you have CH3. So this type of product is generally being formed. So when you have a mixed constituent, let me take another example again for this. Let me take an example of benzaldehyde. So here what you know is over here there is no alpha hydrogen. But next we have this is your benzaldehyde with no alpha hydrogen. But still then the reaction will take place. Okay. Why? Because I'm treating it with ethanol. Here it is being treated with CH3, that is this one, and C double bond OH group. And it's being treated in the presence of alkali, that is dilute and AOH. Okay. So one of the bond will again break, the bond will break, it will have negative charge, it will have positive charge. The hydrogen will attack right there and the carbon will come in contact with this. So the product form will look something like this. We'll have a product which will look like a benzene ring, C, H, here you have OH, next you have CH2, next you have C double bond OH. So this one is your product, basically. So let's move on for the Cannizzaro reaction now. What exactly is Cannizzaro reaction? So our next heading is Cannizzaro reaction. So for Cannizzaro reaction, again there is a criteria. Like in aldol, the necessary condition was there should be aldehyde or ketone, and next there should be alpha hydrogen. But for Cannizzaro's reaction, there should not be any alpha hydrogen. Okay, so basically, how do you come to define this? The reaction between conc alkali, and aldehyde, like formaldehyde and benzaldehyde, formaldehyde and benzaldehyde, aldehyde with except aldehyde with alpha hydrogen. Okay, so what is it saying is you need a reaction between conch-alkali and aldehyde. Okay, and they will form like what type of aldehydes? It can be formaldehyde or benzaldehyde, which do not contain any alpha hydrogen. So if there is alpha hydrogen, then this reaction will not take place. Now, the condition for this is just opposite of that of aldol. Okay, so it should not have any alpha hydrogen. So what does it give? To give a mixture of to give a mixture of alcohol and salt for carboxylic acid. So there we take an example of methanol, C H C double bond OH. Let me take its two group, H C double bond O H in the presence of concentrated alkali. Let me take comp NaOH. So what will happen is it will react to leave alcoholic group, when the bond will break, and here will be the attachment of one more hydrogen, and again two hydrogen group will be added. One of the H group will be added right at this point, and the other H will add right at this point. Okay, so this will be something like this: C H3, and there will be OH. Then we will have alcoholic group along with the formation of HCOO and A. So in one of the group, the bond will break, and what will exactly attach right in this is the bond will break from here, and this will go and attach right in this. And this two remaining hydrogen has been attached right over here with the other carbon. In order to form, this will form H, C double bond O, and A. Okay, so this type of product is formed. This one is your methyl alcohol. This one is your sodium formate. Okay, let me take another example that I have two molecules of benzaldehyde. So there we have C double bond O, H. Again, I'm treating it with another benzaldehyde, C double bond O, H. Okay, in the presence of concentrated alkali, that is conc NaOH. Okay, so what will again happen is again the bond will break from here, and the NaOH will also dissociate right from this point. The O and A group will come and attack at this, and the two remaining H group will come and attach one over here. One of the H will come and join here, the other H will come and attack here. To form a product looking like this, there will be two benzene ring, and here you will have COH, and here you will have CH. Two group, or this will look something like CH2OH. And the other we have is benzene ring, and there you have C double bond O, O and A. Okay, so this one is your Claisen Cannizzaro reaction. You can also do it in the cross form. And if I have a benzaldehyde and a formaldehyde, like, let me show you that one also as an example. So if I have something like this, that one of the molecule is benzaldehyde and the other is formaldehyde, that is H3 double bond OH group. Okay. So the reaction will take place in the presence of dilute, sorry, concentrated NaOH. Conc NaOH. What will happen? Again, the bond will break. The O and A part will come and attach here. And this two remaining hydrogen, this two hydrogen will move and attach, right one at this point and the other right at this point to form alcohol. And so the product form will look something like this. There will be benzene. Here you will have CH2OH group, and the other you will have CH3, sorry, it is C double bond O. It's H, C double bond O, O and A group. That is sodium salt. So this is all about Cannizzaro reaction and Aldol reaction. If you have any queries, do ask in the comment section. I'll surely try to reply. And also I'll try to put some of the question in the description box. Kindly solve that and put it in the comment section. Once again, I would like to repeat that the necessary condition for aldehyde or aldol reaction. The necessary condition for aldol reaction is for aldol, it needs alpha hydrogen, and it doesn't need alpha hydrogen. So that is the only difference. So in this case, if there will not be alpha hydrogen, aldol will not take place. In Cannizzaro, if there will be alpha hydrogen, Cannizzaro will not take place. So that is the scenario. Okay. Thank you so much for hearing me. If you like the video, do follow, share and subscribe. Also, share it with your friends. Thank you.